Now let me give you some examples because the idea of an SPI may sound sort of abstract based on that. So let's give some examples and then give a little more rigor about what SPIs really are. Think about it at the system level, so sort of towards the top of the picture we just saw. A system level SPI would be road testing incidents were caught by a safety driver in testing. And if there are a lot of them, that means you still have a lot more work to go and you're not near safe. You really want to have no road testing incidents the driver has to intervene before it's time to deploy. And there might be some simulator software in the loop and hardware in the loop simulator incidents and so on. And part of the safety argument is that all these types of system level issues are so rare that it's okay to deploy. That means the SPI has to do with having extremely rare incidents, near misses, perhaps even collisions during testing and development to give you confidence that your system is safe. They're going to be subsystem level SPIs. Vehicle controls. Well, how often have you seen the vehicle stability compromised? You need a stable vehicle to be safe, and so loss of vehicle stability should be rare. If you lose vehicle stability, maybe you don't have a crash, but that doesn't mean it's okay. A loss of vehicle stability means that your claim that my stability control system will keep my vehicle able to maneuver might not be true, and so there should be an SPI to measure that. For path planning, one of the things you care about is that you leave some extra margin when going past a pedestrian. You don't want to be passing a pedestrian by 1 centimeter every time. If you do this, something will go wrong. So you may have a buffer, and just simplifying, let's say you need to be no closer than 1 meter to a pedestrian when you pass by them in a certain operational scenario. Okay, but let's say you're consistently at 0.9 meters instead of 1 meter. Does that mean you hit someone? Probably not. But you have an issue that you said you proved you would never be closer than 1 meter, and here you are consistently at 0.9. Something's wrong. You don't understand safety, and if you don't understand safety, eventually something bad is likely to happen. For perception, you look at the false negative non-detection rates. For prediction, you say, well, there's unexpected object behavior. We kept predicting the following would happen, and we kept being wrong about it, so now I can't trust our predictions when I'm claiming safety. Those are the type of subsystem SPIs you would see, are things where it's just not working as you expected. There are also life cycle SPIs. There are maintenance errors. There are invalid configurations. Sadly, those numbers won't be zero, but if you have lots of maintenance errors, that's going to catch up with you eventually and result in a loss event out on the road.